offshore wind energy generation will increase enormously over the coming years. In Dutch waters, a capacity of 4.5 gigawatt is installed. The ambition is to increase this to 70 gigawatt in 2050. To achieve this, we will have to install many wind turbines. We start with the foundations. The monopile is the most used foundation type in the North Sea. The dominant method used to drive monopiles into the seabed is hydraulic impact piling, also known as hammering. This creates underwater sound waves. This sound is spread over large distances through the water and the seabed. The industry developed all sorts of mitigation measures to prevent this noise from harming sea life. However, these measures are time-consuming, expensive, and not always sustainable. With larger wind turbines and foundations, the sound waves also amplify. Staying within the allowed ecological boundaries becomes very challenging. Current measures will not be sufficient. Therefore, the industry is developing new monopile installation techniques that inherently generate less noise and require few to no noise mitigating measures. We present 4 alternatives. With EQ piling, a vast water tank is utilized as a drop weight. This huge tank, filled with seawater, is raised by hydraulic lift cylinders and released upon reaching the drop height set point. The tank falls onto buffer cylinders, which transmit the impact force onto the pile, dampening it to extend the impact time. The result? Significantly reduced noise levels. Another technology is vibro driving. In this case, the vertical vibrations of the tool reduce the soil resistance, and thanks to the weight of the pile sinks into the soil. The vibrojet is a combination of vertical vibration on top of the pile and jetting of water near the pile tip. The water fluidizes the soil inside the pile. This reduces the resistance between the pile and the soil even further. Finally, gentle driving of piles. This technology combines a torsional and vertical vibration. The main driving mechanism is torsion. By definition, torsional motion produces neither underwater noise nor ground vibration. These technologies are still being developed and tested, for example, in the CIMOX project. Current research activities address the applicability for installation in different soil types, the impact of the installation technology on the long-term bearing capacity of the monopile, the actual noise levels and their predictability in computer models to reduce the negative ecological impact, their applicability in decommissioning. The industry is working towards reliable, cost-effective and sustainable installation technologies of monopiles, enabling the scale-up of offshore wind energy.